This is actually part 3. As I looked at the worksheet limit homework 1, I noticed there at the bottom problems 9 through 19 deal with some rational functions, and we really haven't talked about that yet, so I wanted to do that. The limit as x approaches 0 from the right of 1 over x. What you really should be thinking about here is what the shape of 1 over x would look like. And if you can figure out what the shape would look like, you're going to better be able to understand what the limit would be. And 1 over x, you should be familiar with the graph, that it's a hyperbola, looks like that. And as x approaches 0 from the right-hand side, we can see that the y values are getting bigger and bigger and bigger. And so we would say that the limit as x approaches 0 from the right is infinity. Okay, because the x values, or sorry, the y values, or the values of the function, are getting really, really big. Now, to camp out on that for a little while, just to help you understand why that is happening, if you make an xy chart, and if you really think about this function 1 over x, if you replace x with values that are getting increasingly smaller but positive, let's say we start with 1. As x approaches, or when x is 1, 1 over 1 would be 1. So the y value as when x is 1 is 1. But when x is, let's say, 1 over 10, so we're getting closer and closer to 0 from the right. And I'm picking values of x that are getting closer and closer to 0 from the right. And let's see what happens with the y values. Well, here the denominator of this fraction is getting smaller. The numerator is staying the same. Well, what happens when the denominator of a fraction gets smaller? Well, 1 divided by 1/10 is what the y value is going to be equal to. And 1 divided by 1/10 is 1 times 10. Well, that's 10. Okay, so when x got a little bit closer to 0 and y got bigger. Well, then let's get even closer to 0. If x is equal to 1 over 100, then we have 1 divided by 1 over 100, which is really 1 times 100. So the y value is actually 100. And then we can see that the pattern would continue. X is 1 over 1,000, so y is 1,000. So as you get really, really close to 0 from the right, we can see the y values are getting really, really big. And so as x gets closer and closer to 0 from the right, the y values are approaching infinity. You can get as close to 0 as you want and continue to grow that value of y. And that's why the limit is infinity. Okay? So let's take a look at the next one. In fact, if you think you've got it, go ahead and try this one. Pause the video. We have 1 over x minus 3. It's just a translation to the right-hand side, 3 units. In other words, we're going to take the graph of 1 over x and we're going to move it to the right 1, 2, 3 units. That means we have a new asymptote. The vertical asymptote would be x equals 3. Well, x is approaching 3 now from the left-hand side, and remember that graph of y equals 1 over x looks just like this. Well, 1 over x minus 3 looks just like that as well, and we can see that then the limit as x approaches 3 from the left would be negative infinity. Okay, negative infinity. Well, if we didn't want to draw the graph, or if we didn't know what the graph looked like, then what would we do? Well, we could do a couple things. Number one, when you replace x with 3 from the left-hand side, first of all, if you replace x with 3, we get 1 divided by 0. Here's the way I would actually do this problem. If I replace x with 3, because x is approaching 3, and I get 1 over 0, this is really not 0, it's approaching 0. In other words, the denominator is getting really, really small, and I know that when the denominator of a fraction gets really, really small, I know the fraction is going to get really, really big. So I know that I'm going to get plus or minus infinity, and so I'm going to draw a line like this to separate my numerator from my denominator, and this is going to be infinity. Okay, and so you do this a couple times, you'll get it. The numerator is a positive number. Okay, because 1 is a positive number, and no matter what the denominator does, the 1 is going to remain positive. Well, the denominator, on the other hand, if x is approaching 3 from the left, that means that x is going to be 2.9, 2.99, and so forth. And when you subtract 3 from 2.9 or 2.99 or whatever, 2.999, the denominator then, you're going to get a negative number, and so the denominator will always be negative as long as x is approaching 3 from the left. And so positive divided by a negative infinity means that the limit is negative infinity. Okay, so that's the idea. We want to analyze the graph, analyze what the function is doing, analyze the fraction, but understanding the big picture helps us see what we have to do. Okay, and see if you can do this. I challenge you to do this next one here, y equals 1 over x plus 4, without drawing a graph, without doing anything except the way I did that last one, that last part of the last one. Okay, so pause the video and give it a shot. X is approaching negative 4 from the right. We have 1 over negative 4 plus 4. Well, that's 0. So I know that's going to be a positive divided by something, and know that denominator is getting smaller. That means the fraction is getting bigger. Therefore, it's going to either be positive or negative infinity. Now, negative 4 from the right. Okay, negative 4 from the right, and I like to do a little number line. Negative 4 from the right, negative 3, negative 2. So negative 2, negative 3.9, negative 3.99. No matter what I replace x with, as long as it's approaching negative 4 from the right, is going to give me a positive number. Okay, when you add 4 to any of these numbers over here, you're going to get a positive number. So therefore, the limit is positive infinity. And that's it. I challenge you to see if you can work with 16 through, or I guess 15 through 19. Those can be some challenge problems that we do in class, so you can try them on your own, and then come to class and see what you get. So you can check those answers against the answers that you'll see online as well. So I hope that helps, and we'll see you in class.